right. And we're live. All right, thank you for joining me for this session. Such a great numbers. So today I'm going to talk to you about one of the longest projects I've ever attempted and finished, actually. That was actually quite fun because it's technical, and I'm a developer, so I just like technical stuff. So the title is Lessons Learned While Porting 130,000 Lines of Classic ASP Code to C#. While it's precise in like from Classic ASP to C#, I believe that the lessons and the techniques we use are equally applicable in day-to-day life, and I believe that this topic itself is quite important going forward because so many code we've written in all languages, and we just like newer languages more, so we're trying to port the code forward. So who am I? My name is Toni. I come from Denmark. I originally come from Croatia, but now I live and work in Denmark. I'm a lead site reliability engineer. On this project, I was a tech lead, so I'm kind of switched roles in the meanwhile. If you want to connect, feel free to follow me on social media. I include GitHub in social media. So I'll start with the end, basically just give you the highlights so that you can just like, if you get the highlights, you can just leave, I guess. But I promise that it's fun during the talk. So in 18 months, that's how long the project took. We managed to convert our entire Classic ASP codebase to C#, which was amazing. We managed to do it. We had only like 20 regressions. By regressions, I mean any kind of bugs in this porting process. No data regressions, which was very important given that we are a financial institution, but we work with accounting. We had, like I said, 0 database issues. We went down from 257 virtual machines running our application in the Google Cloud down to 57. So you can imagine the licensing cost per Windows machine and also the machines themselves. I'm going to show at the end how much actually that translates to euros per month. Our latency has improved on every single request because we just got 20 years of technology boost in one go from Classic ASP, which is VB script, to C# and to compiled code, not interpreted code, better machines and all that, right? We also removed the language, runtime, improved security and tooling, and there's hidden caveat there. We also improved our, job ads, because we don't have to mention Classic ASP anymore, which is amazing. So agenda, like what are we going to do today? First, I'm going to just give you a short intro into the problem, like why did we even do this? Then it steps in waterfall approach, how we approach it. We might have had more fun than we wanted in the whole process. And then in the end, I'm going to reflect on like why we think this is important as a topic today. All right, so what is Economic? It's a 20-plus-year-old accounting software, for the first online accounting software in Denmark. When it was created in 2001, I think, it was like 5 pages, Classic ASP. Classic ASP was pretty cool back then. C# wasn't even made when they started the project, right? But over time, as Classic ASP died and ASP became ASP.NET, right, and web forms, they started adding features in C# land, and they used this technology called ComBridge, where Classic ASP could actually call on IIS C#. So they started adding more and more code to C#. But the primary core of the software was still Classic ASP. We had numbered forms, which are pages. Form 1, which is the core accounting, was and still is, still was at this moment of the project in Classic ASP, and that was literally the core of the software. It's a debit credit thing where you do accounting and all that. So you can suffice to say it's not like forgot password page. It's literally the core software that's done in Classic ASP. So we started doing microservices at the edge using React. It's painful, but it's doable. And this is how the software actually looked like. So you can imagine on one VM, like one machine, we have running IIS, right? So we have database, which is SQL, SQL, Microsoft SQL. Then we have some service layer. Then we have a bunch of web forms that basically just call C#. It's a classic 3-tier architecture. But on this archaic side, we have Classic ASP code running in interpreter on VM, calling through ComBridge C#. So there is some code sharing. However, if you use async await, C# can use async await pretty nicely. ComBridge cannot use async await because it was made like ancient times. So like all the code here literally cannot benefit from async await code. Everything has to be synchronous, which you might imagine in 2021 when you hire people and you tell them like you can't use async. Like why? Because you can't. That's not fun, right? So what was the issue, right? So we were growing quite aggressively. Like we grew from 62 people to 103 just in the products, not the whole company. The whole company, I think, doubled in size because we have support and marketing and all that things, right? Also, the number of users grew. So like we have more people working on the software. We have more people using the software. We want to add more features because we have to grow. We are also owned by a hedge fund, so you can imagine what the pressure is on us growing. So we have to grow. And Classic ASP is trained. It's not made to work on that scale in terms of people working in it in parallel. It's not type-safe language. And also because you just want to run it more performantly. And as I mentioned before, we had 257 VMs running. So you might say, that's really out of context. Like, what does it mean? At peak times, we had 30,000 concurrent users. So, that's not fun. I did an estimate at one point that, what was it? In certain hours of the day, and not peak hours, but like literally working hours, because it's used only in working hours in the software, right? You could argue that one request was served on one machine concurrently. That means when you're using application, you have your private server for yourself. It's amazing. That's how low performance the Classic ASP was. Because if we introduced less machines, basically saying, okay, now let's run more efficiently, you'll introduce more crashes, which basically annoys both users, I guess, on the same machine. Okay, so why did we want to do it? Of course, we want to remove the language. Nobody really wants to do VB-script. I'm not sure if you're familiar with VB-script. It's not a fun language to work with. We want to grow faster as a company, right? We want to improve the security and performance. You can imagine 20-year-old language and the runtime doesn't have the latest security updates. You don't have async await. You can't use, shiny new, gRPC. We also want to go to cloud, to Kubernetes, because people today are spoiled and they just want to run everything in Kubernetes. So all the buzzwords, right? I don't want to add social ML and all that, but you can imagine. So who are our stakeholders for this whole process? It's basically everyone. Like developers want better code. The SREs wanted just better infrastructure. Nobody likes VMs. You believe it or not, SREs don't like Windows. I don't know why. It's just so strange. Support, most support cases are addressing the shortcomings of the UI issues and the glitches and crashes. And then HR, because we want to hire people, right? We want to hire the best people, and the best people don't want to do VB-script. So we had a project goal that we set out to do. We said, okay, let's go to 0 lines of Classic ASP. We also want to go to 0 data errors. So we're doing accounting. You really don't want to insert wrong number anywhere, right? Label things, okay, fine, but like your what's called PL statement at the end of the year should be spot on, right? We also decided no refactoring. We are just porting, right? Because if you do porting and refactoring, you don't know where the error is, right? Was it the error in porting? Was the error in the refactoring? So just port. We said we want to have good enough code, which means like code should work. We don't care how beautiful it is. We want to remove Classic ASP runtime completely, and that will hopefully decrease fleet size, help us run more efficiently and cheaper. So how do we go about it, right? So there are several options that we can present to our stakeholders, like the C-level executives. We can do nothing. Over time, the cost and risk becomes greater, and return on investment goes, dips because you just can't produce many features, right? Then there is the incremental conversion. We can say, okay, let's port, per sprint 1 page, and that will take forever. Also because you don't have the same learnings, people come and change. And also it goes out of focus. We tried that before, and it just fails. So in 2016, we actually said no further development in Classic ASP. Everything should go to C# and then use Bridge. And we even had a leaderboard where we were like counting who removes more Classic ASP code, and there's going to be a prize at the end. It didn't really work because still teams cannot have focus on that, right? If you have a sprint, you have your goals. Where will you, put in, remove Classic ASP? And these are all like easy targets, like remove unused files, remove comments, remove empty lines. So once you exhaust those, you're like, okay, now I have to do work. Nobody really wants to do that. So we can't really say that we can add one more thing to people's sprints so they can finish it. It doesn't really work. Even gamification doesn't work. So we were thinking, okay, let's do full rewrite, right? Let's just say Classic ASP on one side, C# on the other side, and let's fully rewrite. That is cool in theory, and everyone likes full rewrite. However, it takes so much time. In the meantime, your code is actually the same, so no gain. And then after an indeterminate amount of time, hopefully you do bug-free release, and then suddenly you have like return on investment. This should actually dip, because while you're waiting for the full rewrite, you're literally losing value, right? But it's just illustrative. And then what we thought about is tool-assisted migration. Both me and my co-tech lead in this project. We had previous experience with tool system migrations. We knew it was possible. So basically we said, okay, we can just use tooling to generate C# code from Classic ASP code. It's going to be faster because tools are faster than humans. Speaking of tools, AI, right? So and then we can just shorten the curve. Of course, this is just illustrative, and we're just trying to prove the point. But this is how we thought about the process, right? So when we talk about tool-assisted migration, why is it possible? So I asked you before which language, because I think it's important. When we compare C# and Classic ASP, I can ask you which one is which. Which is upper one, Classic ASP, or lower one? Turns out that the upper one is Classic ASP, and the lower one is C#. And if you look at these sections, they're pretty much the same, right? So that was for us the biggest boon in the productivity, that we could seamlessly migrate front-end part. This is just interpolation, string interpolation. But then when we looked at our code base, we realized that sometimes people splitting things in tiers, n-tier architecture actually pays off. So if you do the correct way, you have database, you have data access layer, then the domain layer, and then the presentation layer, this would be so much easier to do. However, we had this, one page did everything. So it was really hard to kind of decouple these things. So one point, if you are writing code today, it will be ported in 10, 20 years time, hopefully, unless it's dead. So, split your layers somewhat. It helps people in the future. Also, we had some issues with the language. You can see that this value is true, Boolean, right? And then here it's file basket, which it's Danish, doesn't really matter. But file basket is basically an error message. It's a string. So in one block of code, this value switches types. And also, this one is uninitialized. So why is this relevant? Because C# doesn't like this, right? You can't really do two types in one go. TypeScript can, it's better, but C# can't. So that's something that you have to take into account, the problems that the languages bring to the table. So what we decided to do is let's not just argue that it's doable, let's try running a POC. We're trying to figure out if we can do it, how we can do it, can we build it ourselves, can we buy it off the shelf? And also as engineers, we like to build everything ourselves. That's a problem. Even finding on GitHub doesn't really work. We decided to run POC. So we found some vendors and we look at them, made a chart, and we tried to figure out which one we want to pick, and then to go for POC. For us, the most important part was type guessing, because we went to C#, which is a strongly typed language. And then it turns out that it immediately eliminates two vendors, doesn't really matter who they are. And then there are two, and then we pick more green, basically more features that we need. So we pick a vendor, we do test run on a page, we get some semi-compilable C# out, kind of works. We say, okay, this is doable, we can fix it, fix it in post. And then we realize that, it will actually be awesome if we just go and, start porting en masse, because we can learn all the limitations of the software. We can learn how it actually will behave. We can actually test it, It's better to just go straight at it, right? And we also realize that some hard parts of the code are really, tools have limits, right? They're not AI, they're just advanced regexes. So we just figured out that, okay, some parts of the code tools cannot handle, we'll do that manually, but then we can also massage the rest of the code into shape that's better understood by a tool. So that's kind of something that we also figured out. So we did some mass refactoring where we literally removed one construct from the code to simplify the output. And it's kind of interesting approach that you kind of, as you simplify and make your code more regular, it becomes easier for tool to move forward. And then when we proved the POC works, we had all the arguments, we made it a project, we became a strategic project. That was very important. That's one of the key lessons, that if you want to do anything of this size and this length, you have to have someone support from the high above. We were in top 2 quarterly projects for the entire duration of this 1.5 year, which is very important. We also decided to, as I said earlier, clean up the code a bit. And we said, because it's kind of greenfield project, we just assigned a very, very small team, because if you were in the previous session about the number of developers and the speed of the output, it turns out that in this case, 2 developers are faster, because the overhead of communication, the learnings, the pairing, it's so much faster when you have smaller team. And then when you establish the code, then you can actually onboard more people, because now you know that this is actually doable, and you can tell people where they can fit in. Especially in the R&D phase, you really can't do R&D with 20 people, because you don't know what you're doing. You're just experimenting, right? And then later, when we grew, we said, let's get each product team to give us one person, to become our kind of not stakeholder, but adjacent to us, so they can learn about the process. So what did we learn about pre-planning? As I said, it's very important to become strategic. You should also be pragmatic and don't over-engineer. Like the first thing we said, like, okay, I'm going to write a parser. I'm going to write, write everything from myself, from scratch myself. That is actually a trap. Also, one thing that we discovered is because you have Classic ASP code, you have C# code. So what do you do? So you say, I have a code base in one language. Okay, I'm going to write a converter that takes entire grammar of this language and converts it to another one. But that's actually wrong, because you're not making an arbitrary generic tool for any code base. This is a code base where you didn't use half of the features. If you come from C# land, there is unsafe keyword. If you don't have unsafe keyword in your code base, there is no reason to implement code that will port unsafe code to Java, right? Because you don't use it. So in a way, the problem with engineering is that you don't know when to stop. Because you want to solve all the problems ever. Like developers are very good at I want to implement this Boolean in my code base. Super, let's implement the feature flag microservice. No, it's just a Boolean flag, right? Just write a if statement. So we need to figure out how to go down to become pragmatic. So we started doing the project. So we said, okay, POC works, but now we need to kind of deploy it to our customers, right? And we need to figure out when you have POC, it just works. It works on a machine, but you need to deploy it to production, and it needs to work for customers without them being annoyed. And we need to define testing. That's when developers start, okay, this is a project, I have to test things. It has to work, not just pretend to work. So what did we decide? Okay, so let's just split it in phases. And this is how we imagine things are going to be, right? So we spend a quarter. It really did start in Q1. This is not just me being lazy with copy-paste. We really started in January. So we're going to spend a quarter figuring things out, playing, how it works. Then we're going to build some tooling to simplify and speed things up. And then we just cruise until the end, right? We just port page by page, and we call it a day. And then look, it's a good plan. Let's start, right? And then when we started porting, we got non-idiomatic code. I'm going to show that later. And I again marked that you should not port any refactor. So you have this code base. It kind of works, and we have to start marking pages. We have around 150 files, but 300 pages because some pages are used in some files produce multiple pages. We have to mark pages okay, this page is now being converted by a tech team. Do not touch, because if you touch, we have to backport. It's kind of annoying, right? So it becomes a game of cat and mouse. Me and my colleague, we pick 2 pages, we mark them. By marking them, I mean comment at the top of the file. That's what marking means, right? It's don't touch this file. It's Tony's business. And then we realized that it's kind of there are some issues. First, okay, this is kind of bad contrast. It's not the point to read the code. The point is to compare Classic ASP to C#, right? So what we decided to do is that when we port, we keep the code, as I said, non-idiomatic to C#, but idiomatic for conversion. So if you look, it's if sort by number equals 1, if sort by number equals 1. So we keep the same structure, it just add semicolons and parentheses, right? So we just mash it from left to right, so it kind of works. Why is this important? This is important because if there is a bug on the ported code, you can easily do side by side and scan okay, this is different. I can just fix this one thing. Also, if there is any feature or bug fix in this code, because this code is not dead, it's still being slowly worked on, it simplifies backporting. So if somebody adds new else flags here, you can just easily mimic it on the right side without rerunning the tool. So that's the front-end part. On the back-end side, again, this is the Classic ASP code. This is C# code. We actually really wanted to keep it similar. So string concatenation, yeah, SQL injection. String concatenation on the left, string concatenation on the right. Just keep it as simple as that. However, there are some issues. When you switch languages, and this is something that's really important and also depends on language to language direction, right, is that it's not as easy as one might think. There are some quirks in each language that you don't know because you don't that's the thing about converting arbitrary language from to arbitrary language. You don't know the details. Also, when we were running the conversion tool, it spewed out some ugly code which we didn't like, so we kind of tried to refactor it. I know I said no, don't refactor. That's the lesson hard learned. we end up later learning that conversion tool, because they were built to handle this arbitrary problem, they knew more than we did. So they knew about some hidden gotchas in these things. One cool example is if you have an if statement in VB script, right? So let's say if not closed and something else, right? Doesn't matter. If it's A and B, VB script is going to alter the value of the second expression if it's undefined. So if it's just a variable, let's say is open, right? If it's undefined, it will actually convert to 0. So let that sink in. If statement modifies the values it checks. So that's something that's extremely insane, and that happens in one language that doesn't happen in C#. Also, when you have if A and B, in C#, it's lazy evaluation. If the A branch is false, then it just doesn't evaluate the second side. In VBScript, it's not the case. It evaluates both things. So we had to switch from and to just regular and, because that one doesn't do lazy short-circuiting, right? So there's some things that because we saw that in the output, we're like, this looks ugly. It's not like C#. Turns out they were right. So we have proof of viability. We took a couple of pages, we converted them, we made them compile, we made them run, it works. Like we took login page, that was the simplest one. And then we realized, okay, so how does the process look like? We take a page, we port it to C#, we fix everything that doesn't really work, now it compiles, then we kind of test it, now it runs. And then we have to say, okay, so now our customers should access this page. And then when we are done, when it's tested fully, we just remove the page completely, right? And then we realized we had to do this process per page in parallel. We had 300 pages. So you can imagine, like, one day you're porting, then you ship it, then there is a bug. So your mind in one day is like, I'm porting 2 pages, I'm fixing 3 pages, I'm testing 1 page, 1 is rolled out, I have 1 to remove. Like, you can't do this in parallel. You can't really like perceive how to do this. So we rethought our approach. We said, let's port everything, like literally take the entire code base, move to C#, then release it slowly, and then clean up in one go. So kind of like waterfall approach. Which was actually a really good decision. And this is the final actual timeline. So we did still end up exploring in the first phase. So we kind of here decided to switch tracks. We said, let's just sit down and port everything. And this also simplifies because now every page is ported. You don't have to think about it. Then we'll build tooling for support. Then we have our first production release in September. That was our actually OKR goal, key result for this OKR. And then it took us, 3 quarters to basically be done with the full rollout and full testing, because we just did like batching, right? So what did we do to facilitate this? This is, I think, very important lesson that doesn't really, it's not just for ASP to C#. You have to build language adaptation layer. So, for example, len is a function that gives a length of a string. In C# you should do string.length, right? That's how it works. However, that's a problem, because if string is null, this will give 0. If this is null, this gives you an exception. Not the same. Same with abs, and there are some things that feel that you should modify them, but please don't. Also, when I said earlier, when you look code side by side, it's easier if you see len and len, you can like quickly scan and figure out the differences instead of like converting in your head, okay, so this is dot length and blah, blah. So this was actually like what we decided. So our code in C# actually has these functions, which looks like not like C#, but it helps a lot with fixing the bugs and all that. We also figured out that the tool actually was crashing on our biggest central part of code base. So we did like what every reasonable developer does. We use regex. So this on the right side is the full regex script we wrote to basically take a classic ASP page and spew out C#-ish code, which you had to like fix manually because it wasn't perfect, but it brought like 90% you to the finish line. So, and to be able to do this, we exploited one thing, and that was that most of our code pages were actually like very uniformly done, which was amazing. So again, lesson learned: be uniform in your approach. Don't make every page look and feel different. It will simplify later refactoring because you can automate things, right? So this was our architecture to begin with. So what we ended up doing is we added a second layer to the right where we simulate COM-like layer. And then we basically have for every page a C# port, and we use web forms as target because basically the ASP.NET web forms are evolution of Classic ASP. That was our biggest boon. And then 3 months later, we were actually done. Code is ported. Of course, we cheated a little bit. Some of it was hand ported, some of it was deprecated. So we knew that we don't need to do it. But all in all, we're done with migration. And now we need to start testing. And we added 2 new people. So it was now a team of 4 people. And we also need to build some tooling to do the rollout. So what did we learn in this process? That maybe waterfall is actually better because when it's fixed size or like fixed, when project is fixed and knowable, waterfall is better. When project is unknown, then agile is better. So you can say that we were agile in the exploration phase, but then waterfall in the whole approach, right? And we were actually quite surprised by the porting speed. Again, helped by tooling, helped by regex. So it was actually pretty cool. And actually backporting, we realized, we actually found out later that we really need to tell people if they make changes to Classic ASP page, they need to go and fix the C# code. So the code works. By that we mean it compiles on your codebase. Does it really work if you call the web page by URL? It's kind of harder, right? So we don't know if the code crashes, if it works in all the edge cases, so we need to start testing. That's where actually like the real fun begins because, you know, we need to ensure that the code works. We had some BA tests, which are basically end-to-end browser tests, which we leveraged to basically prove that the new code works as before. And then we went in and just tested page by page. That was our process, like take a page and test and learn and then apply the fixes. Also, that lang thing and apps thing actually got improved over time as we figure out more edge cases. So once again, the language adaptation layer is the most important part because we feel that when you have this kind of like similar shape, you can hide all the quirks of one language under the common function name. What does this mean? Example, so CLNG, that basically says convert to long. Given an expression, give me a number. So in C# you would say, I can do int.parse, right? Or I can do convert to int32. That's what it means, right? No, this is the full CLNG implementation that we, over time, evolved to actually cover all the edge cases. For example, if you put numbers in parentheses, what does that mean? That's a negative number in accounting. In VBScript, because it was made back in the day, it works. So if you put like 1 in the parentheses, it will actually be the same as -1. But this int parse doesn't support that. And there are so many edge cases that we also discovered, unfortunately. So this is why it's actually important to keep CLNG in C# code. So if you do conversion from one language to another language, keep those idioms from the old language because they will help. Same with C-string. Again, it's convert to string. How hard can it be? Dot to string. No, again, a bunch of code that we discovered on the fly. And also, it depends on locale. Luckily, we were only Danish, so that was not a huge problem, but still. Another thing is CDate. Like, again, converting to date, how hard can it be? This is my favorite part. So if it's 0, it's December 30th, not 31st. Why would that be? 30th of 1899. And if it's a number, it's basically number of days after that date. So I guess 1 basically becomes 31st. Like, how, why? Yeah, so we can see that those are things you discover. And then at the end, like when you exhaust the edge cases, then you just do datetime parse. So yeah, it's fun. Also, because COM layer was switching from Classic ASP to C#, it also did conversion. So if you pass null, so you have object, it's something. If it's null, it's datetime min value. Otherwise, you convert it with the previous function, right? Why is this important? When you create something over the bridge, let's say you create a new invoice, if you didn't specify, let's say, a payment date, it goes over the bridge and goes to min value. So this ends up in database, right? So when you do like reports, what's done in certain, areas, when you do report on last quarter, last year, if you don't do this, you might end up, and we did end up, with wrong values. Like you would have things that are inside the report or outside report, depending on this min value. So that's also another thing that we discovered. So also be aware of that. This might not apply for every conversion phase, but the point here is to think about when you have marshalling between languages, you have to take this into account. So then we said, okay, so how do we test this code? We have like a page that renders HTML. How do we test it, right? And then you click things on it, and then it works. How do we, can you unit test it? No, you can't. Classic ASP does not have unit tests. So we devised 2 types of tests. First one is output tests, and second one is snapshot tests. So the first one is the simple one. Call ASP page, call SPX page, basically the new page, and literally compare them if they're equal. So this is how the test would look like. You would say, if you call this page, the ASP.ASP, right? You call it with this URL. you literally say the output is HTML, compare it, and also ignore like time query, because if it does datetime now, you want to ignore that part. So this is how, and we discovered these URLs by literally F12 in browser and like comparing. So why did we go this route? We said we're not refactoring, like we are just taking ASP to SPX, they should work exactly the same. So basically the output should not change, given white space, of course, because sometimes indentation changes like 4 characters. That's not super important. So it's a HTML page comparison. We had HTML, JSON, Excel sheet, raw file. Like if you give raw file out, it should be the same file, right? If it's a Excel sheet, it should have the same number of sheets, columns, data, values. So we basically said no changes to the output. So how does this look like? When you say ignore time query parameter, you just want to find certain parts of the page, and then you say that you don't want to compare. These are like exclusions, which are not very. We only have like a handful of those, so it's not super important. Majority of the code stay the same. The things that would change was the order of URL parameters, like in ABC to CBA. That's not a problem because it doesn't matter the order, and things like datetime now in the output, because for cache busting, right? So these are our comparisons which we built. And we had around 10 special compares that would just exclude certain values. How does the error look like? So this is an example output. So here it says this is, which one is up? This is test. So this is classic ASP. It says type equals 0, but in C# it was type equals nothing, undefined, right? It was null. So when it's null, it's unemitted, elided. So that's an example error. So you will have to read this kind of output and figure out what was wrong, and then you have to hunt down the code that prints this this part and see, okay, what should I change? That actually worked like a charm because it proved that if you call the page, it looks the same. But now this is a counting application. You click save. How do you test that? So we actually abused one feature that we had in the architecture, which is a COM layer. So if you remember, like when you call, we have request to web page, this is the file. It basically, whenever it does something, it went over the COM bridge, right? So COM bridge was a unified point of access of data, external functionality, sending emails, whatever, right? So we were like, what if we introduce a recorder here? And basically, every time there is a call, we record the parameters, we record the output, and we record the order of these calls, right? So that way we can basically say, when you call this page with these parameters, you were actually doing this, right? And this was just one layer, so we could just we literally generated this recorder. And then when you want to do replay for the ASPX, the ported page, right? You basically don't call anything. You create this like facade that basically just literally reads JSON files from disk, and it throws if it's unexpected call, or if the parameters are different, right? So that way we could prove that first we discovered short circuiting, like why you didn't call this function? Because obviously C# doesn't call, right? Or the if statements were wrong, or or if the parameters are mangled, like it's null, 0, empty, all those kind of things, right? So we managed to leverage this kind of like facade to record and then replay against against C#. So you might ask, okay, so how hard did we make it for our developers? Well, we were, playing around. So this is how hard it was. We literally said, like, when you build your application, we said we can either update snapshots, so basically generate them from calling a bunch of endpoints, and then we can also compare them by just rerunning them again, but against different URL. We always, when we ported a file, we made file.aspx literally next to it, so that there was like no guessing where the new file is. That's how like close to the original source we were. So if it's file.asp, file.aspx. Super easy to find, convention. How the tests look like? You can imagine they should be complicated, but we said no, they should be simple. So we say that these are like the parameters, right? And we literally say, you call the URL with all these parameters, but because it's not get, it's post, we have extra, we have body, right? So you call the URL, you post these values, you add a special snapshot, and then you compare the output. So you get both in one go. You can get snapshot and output comparison in one test. How did we discover these values? Well, F12, click on the UI, saved values, and it's kind of like, wasn't super fun. That was the most boring part of the job. Basically discovering things and annotating, why did we write these test cases? So it was like, open a page and just guess how many features there are on this page and fix all of them. So what kind of errors could you detect with that? For example, you could detect that between, something's missing here. There should be between and, so the SQL was malformed. That's one way to figure that one out. Then the second one is the value was string before, but now it's a number. In theory, should not matter. SQL should handle it, but we went for like full fidelity. We said like we don't want to guess. If the ASP was sending strings, we will send strings as well. So we caught that one, and we also caught like, for example, this is the most common problem we had: strings versus nulls. You know, in ASP it was empty string, in C# it was null. So that's the most common error we found. And then what we used code coverage, because again, this is like just black box testing. We use code coverage to figure out what we need to test, like how to get like to up some arbitrary value, let's say 70%, doesn't really matter. What we actually were more interested in was reading the source code and then trying to figure out, okay, so this looks like a bit of code that does something, I guess, right? It's actually Bahrain factura for files data, which means calculate due date. So we also, as developers, because we don't really understand the domain of accounting, we're just developers, we also figure out, okay, so this is this important? And we go to BA, like ask them, like, what is this feature? How do you get it in the UI? Because we didn't click enough times to get to this code. And then we actually discovered that some features are dead, because never not used, so the code should not be tested at all. But some are actually important, and this is how you use them. So we kind of discovered features with this approach. It was pretty cool. So the three lessons here to learn is that you should trust your tools, and by tools I mean the ones you write. In this case, snapshot testing and output testing. Like I said, because we can't use unit testing here, and you just have to use black box testing. That was the only thing we could use, right? So you build tools that are your safety nets, right? Then you should involve people. We learned that we can't do it ourselves as developers. We need BAs, we need support because they deal with the application level usage every day. There was like after 2.5 months of testing the most important page application, we called a couple of BAs, a couple of support people to test the application. They literally like on the first click crashed the page. It was like we 2.5 months of testing and you crashed on like first attempt. Like, why would you click there? Never mind. The classic thing that developers are going to say: why would you click there? It's not, but because you can. And also be pragmatic. For example, for our form 1, which is the key central page in application, we involved 2 people basically for a full quarter because it was super important to get right. But there are some pages we just like speed run through because they're used very rarely. We also had, from Cloudflare, we had literally a table of how often each page was used per quarter. Some were actually used by 0, which is like very strange because they use like end of quarter, end of financial year basis. So you kind of have to decide what is more important. You don't test everything with equal. That's actually what our first retro highlighted, that our developers were burning out because they felt that they're like dying on this random page. Like, I'm testing this forever, and like, don't, just skip it. Like, there should be a pragmatic level to how much you test. So now, at the end of this phase, we tested the code. It works. It behaves the same. We believe so. And now we have to ship it to our users. So you have old code still there running, and you have new code tested but not running because we don't give it to our users. So question is like, how do we give it to our users? Also, how do we give it to our users in, let's say, A/B testing phase? 10% get this page, then we can say actually 0% because there's a bug, right? How to do this reliably? So I'm not sure how you do deployments, but in economic, the lead time for deployments is 2 hours. So if you make it one change, not change at all, right? It takes 2-3 hours to get in production. So imagine if you have like a bug that creates wrong data, you have 2-3 hours of people inserting wrong data. You can't afford that in your, we can't afford. So we want to be able to kind of quickly roll back how do this. So we thought about A/B testing or feature flag framework. We had one in place, but given the number of pages we want to port at the same time, it was not feasible to use. So we built a small system called Rewriter. That's basically an IS module. This is just a detailed implementation. It can be done differently. For our Kubernetes Kubernetes migration of the APIs, we actually did it in Cloudflare level, so it can be done different ways. Basically, we basically built a small rewriter here that when you, as a user of browser, you basically go in, and then rewriter is going to check in literally static file, like, is this page rolled out? Basically, is it available to users? And then if it is, it can actually reroute your request to C# side, or just Classic ASP. So by default, everything goes to Classic ASP, and then we say, okay, this page goes to 10% of our users. And then we can roll it back. The lead deployment time was cut down to literally a minute, basically caching time, which is amazing. So it's super simple. You go request, you ask a rewriter, are you already on ASPX? If you got it once, it's a sticky session, you get it all the time. That kind of ensures that if you get a page on ASPX and you post back, you want to post to the same ASPX page. In theory, it should not matter, but we just want to say, okay, you got it once, you got it forever, right? So basically, it's a super simple tool, just sits in memory, reads on every minute, polls the file, did we change something. So if you want to change the rollout value, you literally go to GitHub, edit the file, it takes a minute for it to trigger webhook to update. So lead time, 1 minute. It's amazing to do. So you are a user. Okay, you're a developer. You open a URL and you open a page and it works. Did you get the old page or did you get the new page? It's a very interesting question. So we introduced this corner thingy. Imagine this, like we start rolling out and support is like, oh, there's so many bugs on this page. And you're like, is it my fault? Was this bug before? We actually ported some bugs from old code to new code because we don't refactor, right? Bug was there, bug stays on. So we were actually, because we get screenshots from support, we want to know, like, look, if you look at the screenshot, can you know with 100% certainty, is the bug yours, I mean, ours, supporters, or not? So this was a very cool thing. We just added this to every ported page. So when you get a screenshot, it's like, nah, not my page, ship it to some feature team, I want to fix it. So this is quite interesting thing because otherwise you don't know. Actually, there was a fun story when we were running tests and everything was passing, like 100% the output comparison test, like they're the same. And like, yes, they are because they're calling the same page. It's like comparing ASP with ASP. Of course it works. It is the same page. You're not comparing the new page. So this is important. Okay. So we also built, and this is where we started having fun and in the project, we decided that we don't want to edit file in GitHub. We just want to have nice UI. So we built a release approval UI, where basically you can have a list of pages and say, okay, this page can be now rolled out to users, right? And we also made it so that everyone can read it in organization, especially support, stakeholders, but some people can write it. This is how it looks like, not the best thing in the world. We had, at that point in time, 6 staging environments and 1 production. So basically we'd say that on this staging environment where we give it to testers, like, please test this page, it's 100% rolled out. And then in production, it's 0, as you can see, right? We also noted that this page, like highly problematic, this is what I mentioned earlier, calls per month, actually. This is like 167 million calls per month. So this page, don't F up, right? This page, 3,000 calls per month. It's I think, delete period, delete budget range. Like, no one uses it, right? So less testing, you're more calm when rolling it out because less affected users, right? But also one problem is that when there is less affected users, less chance of you figuring out that the bug is there. So how do we just build the UI? Just say like, okay, so update the number from 0 to 100. That's the rollout, right? Or you can quickly roll back the page from all environments. That's the best thing ever. And then we said, okay, so after 5, I'm going home, right? What happens if there's a bug? So we said, like, we don't want to be on call forever. So we build a small system that if there is more than 5 errors from the Datadog on this page, we automatically roll back. We basically just edit this file set to 0. Because we are in meeting, we are doing something else, we are sleeping, please don't annoy me. So this is how it will look like in Slack. We will get a message saying too many errors. You can just take a quick look, like, what is the problem? And you can click rollback immediately if there's a problem, or you can wait 10 minutes and then it gets rolled back automatically. For example, if nobody responds because everyone was away, it automatically rolls back the application. See, this is an example when I was actually canceling because this wasn't our bug. It was actually a bug that we ported from Classic ASP to C#. So just keep it in production, right? And then we realized also this increase of percentages from 10 to 20 because we did it like every 2 days becomes very taxing. Like, when did I increase to 10%? How should I increase it again? So we basically built auto rollout, basically just literally every morning at 10 p.m. I think, no. 9 a.m., it basically just goes through the list, compares it to 2 days ago. If it's the same, it just increases to the next tier. So in this way, we can also just have automatic rollout increase to our customers. And you can see that if you don't respond, it just goes forward. So we really went for like full automation there. Then we also wanted to monitor performance. We want to prove that this was actually a good effort. So you can see here the green line is the ASP, and the yellow line is ASPX. So this is the same page. This is an invoice header, quite heavily used application page. So you can see that the average, the moving average for ASP was this high, and this is the moving average. And you can also see that the C# it performs more what we call it stable compared to baseline, while ASP, because it's interpreted, depends on how warm the cache is, it oscillates a bit more. So you can see this is pretty much the gain of not calling COM-bridge, of using C#, of using compiled code, and this works per page. So we got like so much mileage out of it. It was very important for us to track this to see that we didn't really improve. You see that's even when it spikes, the spike is still smaller in the Classic ASP, in the SPX phase. So the caveats, one thing we learned is that once we started rolling out, every bug came to our door. Like, because support is like, did you broke it? Like, no, we didn't. That's why we introduced the triangle thing. Also, you roll it out, but then because the page is unused, 2 months later, like, we have a bug. Was it your bug? Okay, I don't know. I don't remember this page anymore. It's been 2 months, right? So it kind of like, it becomes annoying. Also, these tools we built for auto rollout and auto rollback, I think that's the, it's the most fun thing we did, but also I think it's saved us quite a lot of mental energy, because we were pretty sure that that we can just leave work and not just look Datadog all day long, just like, is there an error? Is it an error? No, it's not. So if you want to build something that performs on such a huge scale, like hundreds of files, thousands of lines of code, implement this automation, it will be worth it. And also it's fun. Like, building those tools was more fun than testing Classic ASP, I'll tell you that. So we reached the end of the phase. We rolled out pretty much every page. How successful we were, 100.5% successful. Math is hard in JavaScript. So once we were done, we basically edited the web config to permanently rewrite every .asp to ASPX. We are done. And now it's time to kick the champagne and see what is the benefit of all this. So first of all, we removed the COM-bridge, we removed the Classic ASP, we removed the entire runtime, like we deleted a lot of code. It was amazing. It improved the infrastructure, the code, the local machine setup, amazing. Also now we got typing. Before Classic ASP was like, it was Notepad. Now we have F12, you have type hints. It's amazing. It's so much better. So we get one unified language. Also, in the beginning we were thinking of deleting every page once we port it out. We found that it was kind of like you will lose so much value. There's like a history there, bug fixes, person to blame, right? So what we did, we basically just moved all Classic ASP code to separate repo in case somebody wants to do historical analysis or just check what was the code doing back then, right? It was very important. So this is where we end up, similar to the old part. It's just that now we have C# in web forms and web forms. Twice the fun. So what are the results of this whole process? We improved stability because now it behaves better. We improve performance on every single page. We reduce cost. We improve security because we got all the bug fixes in the meantime. We also got some new issues with security because, supply chain attacks. We improved our hiring because some people actually did not join the company because they said they don't want to work at Classic ASP. They want to work in Kubernetes and the cloud and all that. And of course, the productivity of developers went up. So to illustrate just one thing, this is the Datadog crashes, aggregated over the span. And you can see this is where we rolled out Forum 1, April, and then we were done at the end of June. So you can see that we crashed a lot, and as we kept rolling our C# code out and out, the crashes actually improved tremendously. And turns out that the Forum 1 was actually the biggest culprit of all the crashes. Why is there 3? Because this is crashing of processes, and there is 3 processes that keep crashing in SQL Server. I don't know why. So this is actually 0. So this is how much our stability improved. And also performance gains that we got out of the just 20 years of improvements is just tremendous. Also the CPU usage went down, memory usage went down, so we could just shift down the number of machines. How many? So I said from 257 to 57. We also kept decreasing now because we moved some SOAP APIs to Kubernetes workloads, and we moved some. We are moving internal API that's Web API 2 to Kubernetes, to basically to .NET Core. But this is just a saving from this part, right? It's $46,000 per month saving. So you can just, and this is permanent, right? This is like on a rolling basis. So you can just if you calculate this, this can be a good argument to just spend this budget on developers. This is actually more expensive than 2 developers working on this code per month. So, it pays itself, what I'm trying to say. And now, kind of like just to kind of recap, because I have 55 seconds, so I'm going to speed run. So we believe that this is something that's very important. There's so much code base, and because software is eating the world and already ate it, we will see this thing happening. And I talked to some of you. You also kind of are in business of doing this. We also believe that this is just like, because more developers, there's a cool anecdote. So von Neumann was the first, okay, not von Neumann. First developer was basically, what's his name? Doesn't matter, Alan Turing. And today we have around 10 million developers, right? So if you do the math, it's exponential growth. And if you just look at doublings, that means around how many? 20 doublings per in this 75-year span, which basically gives you doubling every 4 or 5 years, which means on average, half of the developers are what's called juniors with less than 5 years experience. So you can imagine the amount of code being written, and that average developer is basically a 5 year in the market. There's so much bad code out there. Not bad, but it just has to be ported to something better, Golang or Rust or future languages. So this is just a thing that will keep happening forever. And we believe that it's the practices and the attempts we had is a reusable lesson. Also, there's this cool thing I found. Maybe just stick to PHP. That's for the colleague here. Also, other company from Visma asked us about our experience because they had 1 million lines of Classic ASP code that they want to port, and the of the envelope number was $1 million per porting of this, and that's very important for them. So that's how much you can actually, gauge the expenses. Also, Classic ASP is going to be dead in 2025, I think, like completely dead. So expect more of code from that era to be ported, because some companies have rules against using unsupported code. Yeah, and also like my colleague, he works on a different project now where they are running on mainframe, and they have literally, I think, 4 months of runway before they have to switch because mainframe is turning off. So they have to do it. Finally, it's quite a hot topic these days. Will AI help us with this? On one hand, I believe definitely that it's very obvious that the AI is going to convert the code pretty well. However, the testing process, the rollout process, the rollback, that kind of oversight is still, I believe, personally, is human to control. So I believe while you can use AI to convert code bases, and it's going to be easier in the future, you will still have to supervise the coordination. Coordination is a human issue. Doing the task is a tools issue. So I believe that, AI is going to definitely help us with this, but think about the rollout testing process. That's something that still stays with you and your internal processes. Also, just having people assigned to this task is something that AI won't do, hopefully. Well, maybe AI replaces project managers. I don't know. Key takeaways. So this was a long-running project. It was a technical project. It was an R&D project in the beginning, right? So if you want to do something like that, you have to get strategic prioritization. That was for us the biggest learning. That's why it didn't happen before. That's why it happened now, because we had a leader that actually really believed in this and knew how important it is going long-term. And we already are paying dividends, because right now we are moving web forms to Razor, and we are moving SOAP to, we're deprecating SOAP, but we are moving Web API to .NET Core. So we're already going on the next phase of deprecating VMs, because we still have to run VMs because web forms, but we just want to go to full cloud. So it enabled this phase, right? So we're going forward. We believe that tools are not just for porting. You saw tools are for testing, tools are for rollout, tools are for rollback. The whole process should be tool assisted, and we believe that the tools. When I said we, I mean my friend and I, that we used to do this together. We believe that the tools are really important. They give you so much value. And also, at the end, be pragmatic. You should not test every page the same way. You should not port every code in the same way. Like just get the maximum from the minimum and move forward. So that's kind of like the key takeaways. And with this, I'm kind of out of time. So I'll thank you for being here. Thank you for that. And if you have any questions.